Hey everyone, this is Shad, and in the next 5 minutes, I'm going to show how you can identify performance bottlenecks in your Spark application. I'll be using Gigahex, which is a cloud platform, to deploy, debug, and monitor your Spark application. Let's get started. First, I'll register a Spark project in this platform with the same name as the name of my application. Now let's look at the application that I'll be running. In this application, I need to find the population of each city, and for that we have the cities and the people dataset. The application is implemented using data frames and written in the Scala language. Let's go through the code quickly. First, I have passed the arguments to extract the input and the output paths. Then I have created the two data frames, people and the cities, and finally I'm joining these data frames on the city ID and aggregating people on their ID to get the population of each city. Now let's deploy the application. For the deployment, I'll be using Gigahex command line tool, also known as GX in short. This automatically configures my Spark application to publish the JVM metrics, events, and the driver logs to the Gigahex platform without the need of changing my source code. Within few seconds of submitting the application, I'll be able to view the metrics being collected in the dashboard. Currently, it's waiting for the runtime metrics to be received. Clicking on it will land me on the overview dashboard, which shows the aggregated metrics of the application updating in real time. Let's go through them one by one. The ratio of average to the slowest task runtime will let me know if there is a task which has stuck for long. These tasks are quite often responsible for slowing down the overall runtime of the application. We will come back to this to understand the root cause for this slow task. Next is the total executed runtime, which is the total time spent by all the tasks in processing your data. If the time spent in the garbage collection is comparable to the executed runtime, then you can be confident that your application is hitting its memory limits. Now let's look at the usage of the storage memory. The storage memory is used for caching the RDDs, and the percentage used can definitely let me know if I need to bump up the memory configuration for my application. But in this case, we are pretty safe. Executor metrics shows the even or uneven distribution of tasks across all the executors. Ideal executors are pretty common scenario, and identifying such executors would help us to cut down the total number of executors being allocated to the application. And finally, there are a list of jobs created for this application. Each of these have stage metrics. If we look at the first job, which is one of the slowest jobs of all, we can see the reason behind that. There are only 2 tasks for reading the data, and this has been captured in the slowest task runtime metric. In the larger workloads, this would help us to decide on the number of CPU cores to be allocated for parallelizing the read process of the data. Hopefully this would have given you some idea of how to approach the problem of performance. In the next video, I'll talk more about the memory management of Spark and how Gigahex can help you to allocate the right memory for your Spark application. Thanks for watching. See you in the next video.